So reviewing the trig no calculator. On this quiz, you were not allowed to use your calculator. That's why it says no calculator at the top. I'm going to let you have your calculator for all of the exam. It's just too hard to kind of, like you can have it now, you can't have it now, you can have it now, can't have it now. So you're going to be allowed to have your calculator for the whole thing. But if the directions ask for an exact answer and you give me a decimal that's been rounded or cut off, that's no longer exact. So a lot of times trig answers are either going to have pi's in them, which the calculator would round off, or they're going to have like square roots in them, which the calculator would round off. So the way I'll be able to tell that you did it by hand is the fact that you're going to have that exact answer and not the decimal that the calculator would have provided. There are three things that we're going to review from this, three different types of problems. The first type of problem is how we convert back and forth between degrees and radians, or two different ways to measure an angle. And the way we do that is that 180 is equal to pi. 180 degrees is equal to a pi. So we can do substitution. So if you are asked to find what is pi over 2 in degrees, well, if pi is 180, we can just swap that out. And so that would be 90 degrees. Or if I was asked to find 5 pi, if pi is 180, I can just swap that out and get 900 degrees. We can convert the other way as well, that if you start with degrees, what we want to know is how many 180s is this. So to figure that out, we're going to divide it by 180 and multiply it by a pi. So the degrees would cancel. I can cancel those both by 10. And then I want to reduce 27 and 18, both divide by 9 to leave 3 pi over 2. Okay, and that would work back. If you would plug a 180 back into that, you could check your work. 3 times 180 divided by 2 would be 270. So that would get us back to the original. Or if I start with 30 degrees, I want to know how many or how much of 180 is that. So I divide it by 180 and multiply it by pi. I can cancel the degrees then. I can cancel a 10. And I want to reduce 3 goes into 18 6 times. All right, so the key for switching back and forth between degrees and radians is to remember that pi is equal to 180. And all we're doing is switching a unit, just like switching back and forth between inches and feet. Questions on these? The next type of problem we're going to look at is how to evaluate a trig function. So to find something like, what is the sine of 90 degrees? The first step to be able to evaluate a trig function is to graph the angle. We learned that when we graph angles, we do so on an xy axis. Straight out to the right is our 0 line, or our starting line. And we go in a counterclockwise direction. So 90 degrees is going to be straight up. When we land right on one of the axis lines like that, we use our unit circle to evaluate it. So remember, the unit circle is a circle that hits all of the lines at 1 unit away from the center. So that point would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1, just like x, y. And that is helpful for trig because all of those points give us a cosine and a sine, alphabetical just like x, y. So unit circle is a really big thing in finding trig values. So if you don't know it, then that might be a good thing to put on your note card. So remember, you do get a 3-inch by 5-inch note card. I'm not going to tell you what all you have to put on there, but this might be something you would want. So this question is asking us for the sine of 90. So what I need to do then is figure out which one of these points applies. The point at the 90 line is that top point. And if I want the sine of it, I want the second part of that answer, which is 1. That's the answer. Tangent 150. First up is to graph it. So I start at my 0 line. I want to go 150 degrees. We go counterclockwise. 180 would be halfway around. So I'm not going to go quite that far. I'm going to stop somewhere about here. And how much is that little sliver that's left over? 30. So if 180 is halfway and I didn't quite go there, I stopped at 150, I've got 30 left to go. That creates a special triangle. Yesterday we talked about our 30, 60, 90 and 45, 45, 90 triangles. In the 30, 60, 90, across from the 30 is a 1. Hypotenuse is 2. Across from the 60 is square root of 3. In this particular triangle, that square root of 3 is going to be negative because graphically it's going in the left direction. So just like in graphing in algebra, left is a negative thing. Up and down is a negative thing. Okay, so that square root of 3 goes left, so that's negative. The 1 is going up, so that's positive. The hypotenuse is always positive no matter what it looks like it's doing. Then we need to think about SOHCAHTOA. So for tangent, what was SOHCAHTOA? TOA, so TOA, opposite of our adjacent. What then, looking at the picture, is opposite of that 30? The 1. Opposite means straight across the triangle, so the 1 is directly across the triangle. And adjacent means next to, so it is next to that 30? The negative square root of 3. The 2 is the hypotenuse, so we don't want to use that as part of our answer. So that's our answer, and this is how I would know that you've done it by hand and not in the calculator, because if you tried to do this on the calculator, it's going to give you a big, long, messy decimal, because the square root of 3 is not a pretty number. Yes, question?
On my quiz, that's what I have minus. Not for the Spanish, but on my quiz, that's what I have, and I have -1.
Do you have the negative?
Yeah.
Oh, I'll look at that.
Yeah, me too.
Yeah,
I'll look at that. The next one we're going to look at is the cosine of 240. So 240, if I want to plot that, 0 line starts out to the right. I'm going to go 240 degrees around. 180 would be halfway. 270 would be if I went to the next 90 divider. So I don't want to go that far, so I'm going to stop somewhere in here. So how far past the 180 did I go? 60 degrees past the 180 would be 240. I can do 240 minus 180, and that left over is 60. We always want to connect to our x-axis, not just whatever one's closer. It'd be closer to connect it to the y-axis. But we always want to connect to our x-axis. And then we should have a special triangle. Across from the 60 is the square root of 3. Hypotenuse is 2. Across from the 30 is a 1. The 1 is negative because it's left. The square root of 3 is negative because it's down. The 2 is positive because it's the hypotenuse, and the hypotenuse is always positive. So then we want to think about SOHCAHTOA. So what is SOHCAHTOA for cosine? Adjacent over hypotenuse. So CA, so that's the CAH. What is adjacent to that 60 degrees? The negative 1. Okay, adjacent is right next to, so the negative 1 is right next to that. And what is the hypotenuse? 2. One more. We're going to look at an example where the angle is given in radians. So you have two options when your angle is given in radians. The first option would be to convert it to degrees, the way that we did in the last types of problems where we plug in a 180 for the pi and change this thing into degrees. Okay, the other option is to just graph it as is. So if I graph in radians, if pi is equal to 180, then pi is half of a circle. And this question says that I'm cutting that pi into fourths, because the bottom is 4 and there's a pi on top. So I'm taking that pi, or half of a circle, and cutting it into fourths. So I'm going to do 4 pieces on the top, 4 pieces on the bottom. Then the numerator tells me to go around 3 pi fourths. So I want to go 3 of those pieces. So starting at the 0 line, go around 3 of those pieces, and that makes my angle, which I would close up to make my triangle. How big is that angle?
45.
How do we know? The 90 is cut in half, or the 180 is cut in 4, so somehow we can look at the divisions there and see that that would have to be a 45. 45, 45, 90 is 1, 1, square root of 2 we talked about yesterday. The horizontal one needs to be negative because it's left. The vertical one is up, so that's positive. Hypotenuse is always positive. So this one asks for cosine again. So again, we're at AH. What is adjacent to that 45? The negative one. And the hypotenuse? Square root of 2. All right. Questions?
Will you ever have a tangent that says 180 or 90?
Yes, you could have a tangent on the unit circle. Good question. If you had a tangent on the unit circle, tangent is equal to sine divided by cosine. So if you needed to find a tangent at one of those points on the unit circle, you would take the sine answer and divide it by the cosine answer. In a triangle it is. In a triangle, tangent would be opposite over adjacent, but if we have to work with one of the circle values, then we would have to do a sine over cosine. One last type of trig problem to talk about is inverse trig, or like backwards trig. These problems will say something like this. It'll have that little -1 symbol in there. And it will give you a fraction or a whole number, and the answer is the angle. So it's like backwards of the last problem. In the last problem, we were given the angle, and we needed to find the fraction. In this one, we're given the fraction, and we need to find the angle. The key to doing this are 3 important trig pictures. So those pictures are the unit circle, the 30, 60, 90, and the 45, 45, 90. So in this first problem, it has a 1 in it. Everything has a 1 in it here. So I could try to think about like a SOHCAHTOA, and this isn't going to work, so you don't have to write this down if you don't want to, but it would be something that you might try, is to make it 1 over 1 and think about sine as being opposite over hypotenuse. That's a problem, though, because we don't have a hypotenuse of 1. So there's no way to make that work. So our answer is going to have to come from the circle. In the circle, all of the points are cosine comma sine. So this one tells us that we have a sine of 1. So we're going to put a 1 there in the sine spot. And then we want to find where in that unit circle that happens. So where in the unit circle do I have a 1 in the sign spot? At 90. So 90 is my answer. We need to give our answer in both degrees and radians. So we need to turn this thing into radians by thinking about pi being 180 and saying 180 divided by what would give us 90? 180 divided by 2. Since this one doesn't have 1s and 0s, I know it's not going to come from the circle. So then I would want to think about SOHCAHTOA. SOHCAHTOA for cosine, we said before, is adjacent over hypotenuse. So then I need to match up the parts there. I need a hypotenuse of 2, which points me to the 30, 60, 90 triangle. And I need to be adjacent or next to the square root of 3. So what angle is next to the square root of 3? The 30. 90 cannot come as an answer from the triangle because 90 in a triangle has its opposite is the hypotenuse, so that runs into some problems. So if the answer is 90, it'll always come from the circle. Then for our radians, we need to think about 180 divided by what would be 30? 180 divided by 6. Converting to radians. So the directions asked for both radian and degree answers, so that's doing the conversion like we did in the very first type of problem today, where pi is equal to 180. So I want to say 180 divided by what would be 30? 180 divided by 6. This will be our last example. So it's cosine again. So we're going to go with a over h. Then lining up the parts, we should have a hypotenuse of square root of 2 and be adjacent or next to a 1. So what angle has a hypotenuse of square root of 2 and is next to a 1? The 45. I'm just realizing how sloppy I wrote that 45 down there. But that is a 45. And then to convert, we'd want to think about 180 divided by what is 45? 180 divided by 4 is 45. All right, yes?
Is the, when you say like the 180 divided by what? You said you're doing the same thing as the first one?
As the very first type of problem where we converted back and forth between degrees and radians.
So it wasn't divided by 80.
We could. That would work the same way. I just didn't kind of show the work. I did the work in my head, but think about dividing by 180 and put the pi on it, and that would reduce to pi over 4. Yep. So same process. And just these will all work out nicely. I did them in my head. All right. All right. That is the end of the trig review. The one other thing that I want to review with you is circles, and we will do that on Monday, review the Chapter 9 circles. Everything else on the review will be your responsibility to review. So there's probability that we did most recently, so that should be fairly fresh. But constructions and flatland and transformations, those things you would be responsible for reviewing on your own.